Okay, peeps, this is the chemical reactions packet, page 7. I'm thinking at this point you're getting sick of balancing chemical equations. Huh? Not me. I love it. It's so much fun. I will go faster through this one, though. And what you need to do is you need to email your teacher if you are struggling with one of them or if you don't see why one of them balances the way it does. And definitely email me if I make a mistake. I am certain somewhere in all these videos there's got to be several mistakes. Okay, so let's see. We need 2 nitrogens over here, and that gives us 6 hydrogens, so 6 on this side. Potassiums are balanced, chlorines are balanced, oxygens are going to both need to be to 6, so that's 3, gives us 6 here, 2 gives us 6 here, and that right, like 6 oxygens. But my potassiums and my chlorines, I just doubled them. I have 2 of them now, so I need a 2 here. Let's see, sodiums are good, chlorines are not. I need a 2 there, which means I need a 2 here, and that balances it. Oxygens, I need a 2 here and a 2 here. Lead, let's see, the hydroxides, I have 2 oxygens, so I'm going to need 2 here. And so that's 2 oxygens and 2 oxygens. And look at the hydrogens. There's 2 hydrogens here, but there's 4 on this side. 2 times 2, there's 4 hydrogens here. So if I put a 2 here, I'll have 2 hydrogens here and 2 hydrogens here. I'll get to 4 on this side also. And that fixes the chlorines too. See that? This is 2 chlorines and that's 2 chlorines. It usually works out. If it doesn't work out, there's some mistake somewhere in one of these subscripts or something. So if it's not working out for you, something's wrong somewhere. Okay, the aluminums. The sulfates stay together, so I'm going to leave them together. Notice I have 3 on this side. So, right, there's 3 of this whole thing. SO4 is called sulfate. It's a polyatomic ion. Remember, it has a -2 charge. So there's 3 of them on this side. So what if I jump straight to putting a 3 there? And I can see these aluminums have 2. What if I put 2 here? That gives me 6 bromines, 6 potassium, so that's a 6. And do my aluminums? Yeah, and aluminums are good. Yeah, okay. Okay, all 3 of these are going to be a mess. All 3 of these are the same. Remember, we're going to be driven by the oxygen to have an even number of oxygens. So to balance the hydrogens, to get them up to 4, I could just put 2 here, and that will give me an even number of oxygens. I'll have 2 oxygens here and 2 oxygens here. That's 4. And I can put 2 here, and that's another 4. So there we go. All right. This one, did we just do this one in the last page? If I put a 4 here, that's 8 hydrogens, balance that hydrogen, and that's 4 oxygens, right? So oxygens are 4 here. And then to balance these carbons, put a 3 here, and that gives me 6. So 10 total oxygens, so I need a 5 here. This one, if you look, I need to get to 18 hydrogens. I pretty badly want to put a 9 right there. If I put a 9 right there, 9 times 2 is 18. But I can't put an odd number here. Because if you put an odd number here, you'll have an odd number of oxygens, and we can't have an odd number of oxygens. So what do I got to do? The hydrogens on this side can only be either 18 or double that to 36. Right? Can I do math? Yeah. So if I put a 2 here, that doubles the hydrogens up to 36, and which means this needs an 18. 18 times 2 is 36. And 18 times 1 is 18 oxygens here. right now with this water, with all this water. The carbons, 2 times 8, there's 16 carbons. To get myself 16 carbons on this side, I put a 16 here. 16 times 2, there's 32 oxygens here. So 32 and 18, there's 50 carbons. I mean, it's 50 oxygens on this side. That's a lot. So to get 50 on this side, remember, it's a multiplier, so you need 25. All right. Let's see, this one. The oxygen, you know what? The hydroxide stays together. So we can just count them directly. So 3 hydroxides on this side, I want 3 hydroxides on this side. 3, then that changes. Remember OH? OH is a polyatomic ion called hydroxide. It has a 1- charge. And it didn't break up into its parts, so we can count it as one thing. So 3 sodiums, that gave me 3 chlorines, which works out. Okay. Oxygens, I can see they're both going to need to go to 10, so 2 and 5, and that gives me 4 phosphoruses. Number 12. Number 12, right now we have 3 hydrogens to this 2. So if I put a 2 here, that gives me 4 hydrogens, 2 oxygens. If I put a 2 here, 2 sodiums, 2 oxygens, 2 hydrogens here. 2 hydrogens, and right now 2 hydrogens here, and this is 4 hydrogens. So the hydrogens are balanced right now. If I put these in, the oxygens are balanced. 2 times 1 is 2, and 2 times 1 is 2. I just need to fix the sodiums. Okay. Oxygens. Notice, by the way, when a metal, that's silver, Ag. When a metal is by itself, just sitting there alone, it's the easiest thing to balance. You can put any number here to fix it. So do that last. So let's fix the oxygen first. So 2 on this side, but only 1 on this side. So double that. That doubles, so that's 2 times 1. So I got 2 oxygens, and now 4 silvers. So that's easy. Okay. So let's see. Sulfurs, we got 8 of them on this side. So this needs to be an 8 here. And will that work with our oxygens? 8 times 3 is 24 oxygens. How do we get 24 here? We need a multiplier. All right, we're good. Hey, this is the equation for photosynthesis, opposite of the one we did earlier, right? We just need some sun as the energy here, right? Plants breathe in carbon dioxide and get water in their roots, and thanks to the sun's energy, they make sugar and release oxygen for us. Cool. Okay. If you see, I already know how this is going to balance. The carbons that will balance to 6. The hydrogens need to go to 12, so that needs to be a 6. So that brings the carbons to 12. And if you look at what's happening with our oxygens right now, this is 12 and this is 6. So I got 18 oxygens on this side. If we put a 6 on this right here, that's 12 here plus this additional 6. Do you remember when we did the marshmallows in biology? You first built this one glucose molecule, and then you broke it up. You built one of these and 6 of these, and then you broke it up and rebuilt 6 and 6 of these. Okay. This guy's already balanced. That's cool. Okay. This one, this is a carbonate ion, a carbonate polyatomic ion, but we can't count it by itself because it breaks up into carbon and oxygen pieces. So we have to separately count them. So let's see. The calcium's already balanced. The chlorines, the chlorine, that's pretty easy. Is that gonna be able to stay with the oxygen? Oh, actually, that's it. That balances it. 3 oxygens here and 2 and 1 more. 3. Okay. All right. That was easy. Number 18. This one, the that NO3, it does stay together, so we could count that separately. But then this is a bicarbonate ion that breaks up, and so we can't count that separately. Let's see. The nitrates are good. The hydrogens, oh, this thing's already balanced. There's 2 hydrogens on this side, and there's 1, 2 already on this side. And there's 1 carbon here and 1 carbon here, and we already counted the nitrates. They're already good. The sodiums are good, and then look at the oxygens. 3 here, and 1, 2 here. 3 on this side. Sweet. Okay. Let's see, we have 3 oxygens on this side. So what happens if we multiply this? What if we do this? That gives us, what if we do this? Wait, 4, yeah, okay, does that do it? Right? 4 hydrogens on this side, 4 hydrogens on this side, and then oxygens are 2, so we got 4 oxygens now on this side, and this one we have 4. Okay, so that did it. Okay, this next one, sodiums, fluorines are not balanced, bromines are not balanced. Let's see if we put a 2 here to balance these bromines, then that just changed our sodiums also, so we need a 2 here. And that just doubled our fluorines, which is good. We needed that. And the calciums were already balanced. Okay. All right, for this one, we got several polyatomic ions here. We got sulfate here and here. All right, SO4 is sulfate. And we got NO2. NO2 is nitrite. So, and they don't break up, so we can count them on their own. So they're balanced right now. 1 nitrate and 1 nitrate, and 1 sulfate and 1 sulfate. But the sodiums aren't balanced. We have 1 here, but 2 here. And the hydrogens aren't balanced either. So if we fix the hydrogens first, 2 on this side, we'll need 2 on that side. But so that doubles our nitrites also. So we have to double our nitrites here, and that works out for us because we needed to double the sodiums. All right, good, balanced.